So solving natural log equations. A natural log is just a specific type of log. It's a log where the base is the number e. So when we're talking about natural logs, we write them as ln of x. So they have their own specific little symbol instead of log, which makes it easier for us to also type into our calculator because our calculator has a log ln button. So we don't have to worry about the change of base. But natural log is the same thing as saying log base e of x. And remember, e is just that number 2.71. It's like pi, right? Except for it actually represents, if you were to compound something continuously, that's the number that it represents. So if something happened over and over and over and over and over and over and over as many times as possible, that's where e comes from. And natural logs follow our same properties as regular logs. So we can expand them, we can condense them, we can worry about them. Exactly the same as regular logs. So if we wanted to condense these natural logs, if we wanted to condense the natural log of 7 plus the natural log of 5. And the only reason I like to write it as a cursive L, just because of my handwriting personally, if I write it as a regular L, then I'm like, is it an L, is it a 1, is it an I? So I always use a cursive L just to make it easier for myself to follow my own work. So ln is just the natural log. I have ln of 7, right, plus ln of 5. So since they're adding together, I can make them one natural log, and I just bring them together and multiply, just like I would if they were regular logs. Anything that's inside the parentheses like that, inside the natural log, we can simplify further. So we could actually do 7 times 5 there and simplify it. If we had numbers inside the parentheses and numbers outside the parentheses, which we'll see with the next example, we can't simplify them because they're separated by those parentheses. So this can really become natural log of 35. And I can write it as natural log of 35 just like that, or I can write it as a natural log of 35 with parentheses. Most of the time you won't see the parentheses unless you're adding or subtracting something inside the log. Then they use the parentheses to make sure you know that all that stuff is inside the log. If there's just like one number in the log, they won't put parentheses around it because they know that you assume it's in there. But both of them are correct. All right, so let's look now. I'm going to zoom into this one. If we have 1/3 times the quantity of the natural log of x plus the natural log of 8 minus 4 natural log of y. I'm going to go same way, order of operations. I'm going to do what's inside the parentheses first. So the first thing I want to do is bring this together. So I'm going to keep the 1/3. I'm even going to keep the parentheses. I'm going to condense it so I get 1 natural log. Since they were adding, I know I have to multiply them. So that means I'm going to get 8x minus 4 natural log of y. So first thing I did was bring it together. Now I notice that both of my natural logs have numbers out in front of them. Do you remember what those numbers mean? They're really the exponents, right? So I can really bring this up and bring this up, right? They both come up to be the exponents. So if I'm going to rewrite this, now I have the natural log of 8x to the 1/3 minus the natural log of y to the 4th. Now I specifically put parentheses around the 8 and the x because 8x to the 1/3 is not the same thing as saying the quantity of 8x to the 1/3. This one only the x has the 1/3 power, whereas here, the whole thing has the 1/3 power. So since that entire natural log had the 1/3 power, I needed to protect that 8x with parentheses. I could have also put the parentheses just around the entire thing. Would have been correct too, but I have to make sure that I keep that 8x connected so that that 1/3 power belongs to the whole entire thing, not just the x. All right, so then I can bring my natural logs together because I still have two natural logs. So I can say, okay, I have one natural log. I'm going to take everything that's in the first natural log and divide it by everything in the second one because they're subtracting. So my numerator is 8x to the 1/3 all over y to the 4th. That one was intense.
You lost me in like the third step.
In the third,
It
when I
wasn't on the last one. I don't know how that's the last one.
with the parentheses around the 8x. Is that where I lost you when I started talking parentheses?
You just took that one and that one and put them over each other.
Because they're subtracting.
Because that's how it's condensed. That
Right.
part I understand.
Okay.
The part before that,
The parentheses around the 8x. Okay, so I could have written it two ways. I could have rewritten this. When I bring this 1/3 out in front, I could have kept it exactly the same. I could have said ln of 8x all to the 1/3. I could have done that, right? Because I need to bring that power up. But I don't really love that because it's like, it looks complicated. It confuses me when I go to rewrite,
Yeah,
like
me
when I
too.
go to condense it, right? So I knew that I needed this 1/3 to apply to this entire thing. So I couldn't just say ln of 8x to the 1/3 because that only applies the 1/3 to the x. So I had to make sure I needed it for all of it, so that's why I put those parentheses in there. Then from there I just divided the first one over the second one because they were subtracted. That's like as intense as it gets for when we're condensing. So we also have, just like with logs, how we had those rules that allowed us to simplify things when we were solving or condensing. We have some nice, pretty rules for natural logs that when we see them, we can simplify to get prettier answers. Anytime you see ln of 0, or anytime you see the natural log of 0, that is undefined. So you're done at that point. That problem is undefined. That's not a number. There's nothing you can do. This is undefined. The reason it's undefined is because it's really like saying log base e of 0, right? Because ln is just log base e. And if I rewrote that, if I didn't know what it equals, I could rewrite this to be e to the x equals 0. And e to any power is never going to give you 0. You can never get a 0 out if you're multiplying e over and over and over by itself, right? The only way you can get 0 is if you multiply it by 0. So if you're multiplying the same thing over and over and over again, there's no way you'll ever get 0. So anytime you see natural log 0, undefined. Anytime you see the natural log of 1, you can change it to a 0. Same thing, natural log of 1 is like saying log base e of 1 equals x, which means e to the x equals 1. And we know if we want to get an answer of 1 or exponent has to be a 0. So that's why ln of 1 gives a 0. Ln of e gives you 1 because ln of e is really log base e of e, and we know when the base and the number in the log are the same, it equals 1. Which makes life a little bit nicer, so when you're simplifying things, or when we're going to get to solving it, anytime you see these, you can cancel the natural logs and just turn them numbers. So using our fancy new rules, we can take things that look super scary, like the natural log of e to the 8th, and we can simplify it to be very, very pretty. Because we know if we have a power, right? If we have this power up here, I can bring the power down in front. So I really have 8 times the ln of e, or the natural log of e. And we just said natural log of e simplifies to be what? 1, right? So I really have 8 times 1, which is just 8, which makes that nicer. The shortcut there is if anytime you see ln and e next to each other, they cancel out. So you immediately could have just gone like this in your mind, knowing that rule, and said, ooh, ln and e together, so I got an 8. Without me showing you, do you have an idea of what the next one would be? What are we thinking? Yeah, it's going to be 1/2, right? Because I can take this 3 and bring it out in front. So then I get 3 ln of e all over 6. My ln and e cancel out to be a 1, so I really have 3 over 6, which is the same thing as 1/2.
Wait, why does the letters go away?
Why did the ln and the e go away? Because that was one of the rules that we just talked about, that ln of e, or the natural log of e, is just 1. Yep. And anytime we're multiplying, if I multiply by 1, it doesn't change anything. So really, if I was showing my work correctly, I should have said ln of e becomes 1. It really looks like that.
Perfect. I just hit my head on this, and she laughed at me. That was not fair.
Oh, good. Lovely.
Oh. No, we're not.
What about if we wanted to solve the natural log equation? So if I gave you something like ln of x equals 2. So the natural log of x equals 2. If we had an e and an ln together, we can cancel it. So knowing that logs and exponentials are opposites, right? We knew that from the beginning, they're inverses of each other. I need to get that natural log out of the equation because there isn't a natural log on both sides, so I can't cancel it. Yeah, so as long as I do the same thing to both sides of an equation, I can do whatever I want to both sides of an equation. So I intentionally want to get rid of the natural log. So in order to get rid of the natural log, I need to use the opposite of it. The opposite of it would be an exponential equation. So I'm literally going to, I'm going to use purple, make both sides of the equation the exponent of the letter e. So I'm going to create, because as long as I do the same thing to both sides, I'm going to raise the equation to be the exponent on both sides. So I'm going to apply that e, but the e is going to be the base. Does that make sense? Kind of. It's wild, right? You're like, what the heck? Why would I ever make something into an exponent? But it's going to make it very, very beautiful. Because now I have an e and an ln together, right? So I can cancel this, and I get x equals e squared. And as far as I'm concerned, that's your answer. And as far as an AP Calc class would be concerned, that would be your answer, because that's super, super accurate. So why was I able to cancel that out? So I can cancel this out because technically, if I have this ln of x, I really have e to the log base e of x, right? Because ln is just, right. And anytime, that was one of our rules from logs, anytime we have a log as an exponent, where the base of the log and the base of the whole thing is the same, so when this matches this, they all cancel, and we're just left with whatever was in the log. So anytime I have this ln and the e next to each other like this, they cancel out, and just leave me with whatever's in the x. So then I just have x equals e squared, and you can leave that as your answer. Your homework is going to ask you to take it and turn it into a decimal because it's a pain in the butt for you to have to type in the answers the way they come out. So when you go to do that, I would get your final answer and then type the whole thing into Desmos the way you see it to get the decimal. Because if you start rounding as you're solving, you're going to get the wrong answer. Does that make sense? All right. What about the second one? ln of 3x plus 5 all squared equals 4. So we could square it if we wanted to, but then we're going to end up with an x squared, right? We wouldn't be wrong, we'd just be making a little bit more work for ourselves. What else do we know about powers? They can go out in front, right? So let's bring that power out in front, because if we do that, now instead of squaring the whole thing, I'm just multiplying it by 2, right? So then I have 2 natural log of 3x plus 5 equals 4. And if I'm multiplying something by 2, how do I get rid of it? I can divide both sides by 2, right? So I'm going to divide by 2, divide by 2. So then I get my natural log of 3x plus 5 equals 2. And now I've got to get rid of my natural log. So anytime we're solving these, we want to get that natural log by itself. If there's stuff outside of the natural log, if we can add or subtract things and move it to the other side, we always want to do that first. Get the natural log by itself, and then get rid of the natural log. So anytime I want to get rid of the natural log, I'm going to make both sides my exponent, because doing that is going to cancel my ln, and I'm left with 3x plus 5 equals e squared. How do I get rid of a plus 5? I subtract it, right? So then I get 3x equals e squared minus 5. How do I get rid of a 3? Divide. So then I get x equals e squared minus 5, all divided by 3.
That's the answer.
And that's the answer. What?
You showed this to somebody who had no idea what breakout was about. I can probably
This.
because I am a breakout and I'm having a breakout. Please explain how you're talking to me.
All right. Do you want to see 2 more of these, or do you want to see a different example? How do you feel about this? Do you need another example of this?
No, pretty easy. This is easy.
You're okay? All right. So let's skip these 2. And let's go the opposite way of if you needed to use a natural log in order to solve the exponential equation. So now you don't have an ln, but you do have an exponential equation that has an e in it, and you need to use the ln in order to solve it. So you've got 2e to the negative x plus 3 equals 25. So we've got to get that x all by itself. So the first thing we always want to do is anything that we're adding or subtracting or we're multiplying and we can just move to the other side like we were solving equations, we want to do that. So right off the bat, I'm going to subtract 3 on both sides. When I do that, I'm left with 2e to the negative x equals 22. I'm going to divide by 2 on both sides. I'm left with e to the negative x equals 11. And now I've got to get rid of this e, right? but we know we have that rule that ln and e cancel each other out. So I can literally apply the ln to both sides of this equation so that I end up getting negative x equals ln of 11. And anytime I'm doing this, I intentionally always use protection around my natural logs. Anything that I put the natural log in front of, I keep it in those parentheses so that I don't accidentally add or subtract things to that number. So like if I had a 3x here, I'd have to then divide by 3, but I couldn't divide that 11 by 3. It would just go in the denominator and it would hang out there. So I always protect whatever's in my natural log so that I remember not to accidentally simplify things that are protected by that natural log.
So does it just decide to go in a little LN?
Yes. As long as I do the same thing to both sides, I'm not breaking any rules.
Oh.
Yep. So then I just have to get rid of that negative, right? I divide by a negative, and I get negative ln of 11. Now the difference with b, where I have e to the x minus 2 equals 12, the difference there is I can't add 2 to both sides until I get rid of the exponential equation because that 2 is up in the exponent. So I can only add and subtract and multiply things that are not in the exponent until I get rid of the e. So here the first thing I can do is apply the natural log to both sides. So when I do that, I get x minus 2 equals the ln of 12. And this is what I was talking about. So this is why I definitely want to make sure I protect that 12 with parentheses, because now I need to add 2 to both sides. So when I add 2 to both sides, I'm not going to get the natural log of 14. I'm going to get x equals the natural log of 12 plus 2 on the outside. That natural log is its own term, and you can't combine it with things that are just plain numbers. So it just gets kind of tacked on along the end. What do you think? This is all you've ever dreamed of for the last lesson in pre-calc for the year?
No.
Do you want to see another example, or
No, I just don't understand like how did you know when to stop?
once my x is all by itself?
Okay.
Yep. So once my x is all by itself, then I know I've got my final answer.
Okay.